This is for Year 12 Specialists. It comes out of Chapter 8, 8A, question 17. Part A says show that this curve has only one turning point. Okay, so I've got to take the derivative and show that there's only one solution to the derivative equaling 0. So I've expanded the denominator, so I've got 3 on top of minus 2x squared plus x plus 1. So if I take the derivative of that, that's the same as having the derivative of 3 times minus 2x squared plus x plus 1 to the power of negative 1, which is a chain rule. So the derivative is going to be 3 times negative 1 times minus 2x squared plus x plus 1 to the power of negative 2. Then the derivative of the inside is minus 4x plus 1. Which gives me minus 3 on top of minus 2x squared plus x plus 1 squared times 1 minus 4x. And if I set that equal to 0, I'm only going to get one solution. It's going to come from this factor here, and it's going to be at x equals 1/4. That's the only solution, because this here won't give me anything that will give me an answer of 0. So, show has only one turning point. Yep, it only has one turning point. Find the coordinates and the nature and determine the, okay, so the coordinates will be 1/4 and 3 on top of 2 times 1/4 plus 1 times 1 minus 1/4, which equals 3 on top of a half plus 1 is 3 on 2 times 3 on 4, which gives you 3 on top of 3 on 8, which is 9 on 8, which is 8 on 9, which gives you 8/3. So 1/4 and 8/3 is the turning point. And to determine its nature, what I need to do is I need to take my derivative, which is d dx, and that's the derivative equals this. I know that at 1/4 it's going to give me an answer of 0. I know I have asymptotes at x equals -1/2 and x equals 1. So if I use x equals 0 and x equals 1/2, I can then determine what type of stationary point it is. So when x equals 0, the gradient will be, that's negative. If I put a 0 in there, that's times positive. If I put a 0 in here, I end up with 1 squared. That's a positive as well. Therefore, negative. At 1/4, it's equal to 0. If I put in 1/2, I would end up with -3. 1 minus 4 times 1/2 is 2, so that's negative. And I put in 1/2 in here, I'm going to have, no matter what it is, it's going to be squared. It's going to be positive. Therefore, that's going to be positive. So I have negative, 0, positive. Therefore, it is a local minimum.